Today we are going to go over day 2 of lesson 5, dealing with negative exponents with powers of 10. Let's begin. Our goal for today, I know what it means if 10 is raised to a negative power. Let's see what happens when exponents are negative. So I want you to work along with us. So open up your workbook to page 27 in the illustrative math workbook. If you don't have your workbook, that's okay. You can still follow along. So it's on page 27, you're going to see a chart that looks like this. Let's kind of go over this. So we're asking you to fill in the blanks. So if we're asking you to do each row going across. So we have using exponents. So you can see we have 10 to the third, 10 to the second, 10 to the first, and then fill in the rest. As a decimal, we know that this number 10 to the third is 1,000. We're going to have to fill these in. We know this is 1, so we're going to fill in the unknown by using what's given to us. And then we have this as, remember how to read decimals, so we have tenths, hundredths, then thousands, then 10,000s, then 100,000s, then millions, and so on and so forth. And last row is dealing with fraction. Notice it's going to be whole numbers. We'll have a 1 underneath it, and then beyond that will look like a fraction, a numerator of 1, and then our power of 10, whatever that exponent is underneath in our denominator. So also what we have at the top, we notice we see these arrows, and we're multiplying by 10, so factors of 10. So if we start at where we know 10 to the first power times a factor of 10 brings our answer to 10 to the second power. So we're gaining a power. So if we want to gain a power, we're going to multiply by 10. So we're dealing with a base of 10, factors of 10. We're multiplying each time we want to get bigger, we're multiplying by 10. And on the bottom, we don't know. We got to figure out, we're still multiplying, but what are we multiplying by to figure this out as we go on? So I want you to pause the video, and I want you to complete the table to explore what negative exponents actually mean. As you work, complete the table one row at a time to see the patterns most clearly. So pause the video, fill in as much as you can. Hopefully you can fill in the whole chart. All right, let's go over this. Starting on the using exponents row. So we went from 10 to the third, 10 to the second, 10 to the first. You can see that we're going down. So if we kept going, this would be 10 to the 0 power, 10 to the negative 1, 10 to the negative 2, and 10 to the negative 3. So if we follow our arrows, if we're multiplying our power by 10, we're getting closer. In this case, we're getting closer. Where our number is going to get bigger. In this case, it's getting closer to 0. And once we get to 0, it gets bigger. The exponent comes 1, then 2, and then 3. So we're multiplying by 10 each step all the way, factors of 10. So moving as a decimal. So if 10 to the third is 1,000, if you notice, it has 10 to the third is a 1 with 3 zeros. Here, 1 with 3 zeros. Now our number's getting smaller, so it's going to be 1 with 2 zeros. So in this case, it's 10 times 10. So 10 times 10 is 100, times 10 again is 1,000. This would be 10 times 10, which is 100. This would be just 10. And we remember that 10 to the 0 power is 1. If you notice, as we're going from left to right, our number is getting smaller. Our decimal is actually going 1 to the left each time. So if it's here, we're going 1 to the left, it becomes 100. Going 1 to the left becomes 10. 1 to the left becomes 1. So if we continue that trend, 1 to the left, it's going to be 0.1, 0.1. And then 1 more to the left, so it's 0.01, which is, we say this as 100th. And we'll move 1 to the left, which is 1,000th. Then filling in our last row, writing this as a fraction. So remember, when we have a whole number, in this case it's 1,000, we just put 1,000 over 1. This one's done for us. 100 would be 100 over 1. This would be 10 over 1. 1 over 1. Now, what we're doing is where our number becomes more of a fraction than we're used to. It's be 1 over 10. So this is 1/10. So we raise 1/10. This is 1/100th. So our number now is going to grow a 0. So it now becomes 100th, and then 1 to 1,000th. So one thing to really think about, as you move towards the left, each number is multiplied by 10. So our number is getting bigger. If we want our number to get smaller, we're going from left to right. What are we going to multiply by? Think of multiply. If we want to go from right to left, we're multiplying by 10. But if we want to go left to right, so we want a number, we're going from pretty big to smaller, we have to multiply by 1/10. So each one is going to be multiplied by 1/10. So how can we write these expressions with negative exponents as fractions? So if we knew 10 to the 7th is 10 times itself 7 times, or 1 with 7 zeros, 1, 2, 3, 4, 5, 6, 7, so that would be 10 million. Then 10 to the negative 7, remember what we said when we're dealing with negative exponents, we're really multiplying by 1/10. We have to do that 7 times because it tells us 1/10 times 1/10 times 1/10, 7 times. Or if we wrote that out, 1 times itself 7 times is 1. 10 times 10 times 10. So we're going to multiply that 10 times itself 7 times, so it should be 10 million. So what do we notice here? When we have an exponent that's positive, 7, we knew that was equal to 10 million. But when we're dealing with negative 7, we got to think of this as a fraction. So it'll be 1 over 10 million. So we have 10 million as a whole number and 10 million as a fraction, 1 over 10 million, when we have a negative exponent. So let's look for some more patterns. Do you see what 10 to the first equals 1? 10 to the 0 power equals 1. 10 to the first equals 10. 10 to the second equals 100. And 10 to the fifth equals 100,000. So as we increase the exponent, we multiply by 10, which means we're adding another 0 to 1. But we can also look at this as moving the decimal point. So if we knew 10 to the fifth, 10 to the fifth is 100,000. We just move the decimal places 5 places to the right, starting behind 1, which is where the decimal place starts. So if we did that, 1, 2, 3, 4, 5. 5 decimal places, because it tells us an exponent of 5. So when we write 10 to the negative fifth as a decimal by moving the decimal point 5 places, this time it has to go to the left, behind the 1. So if we're here, we're going to move it 5 places. 1, 2, 3, 4, 5. When we see this negative exponent, it should tell us our number is going to be rather small. It's going to be less than 1, but more than 0, unless this is a negative base. So take another look at the decimal row of the table. Do you see how the decimal point is moving left or right? So if you go back, see how our decimal place moves. And I kind of mentioned this before. So if we're going from right to left, if we are growing, let's go from right to left. We're growing, so we're moving our decimal if we want to get it bigger. So if we're at 1, we want to go 10 to the first, we're going to move it 1 to the right. It becomes 10. 10, and we want to multiply another factor of 10, we're going to move it 1 to the right, which becomes 100. All right, so let's get back to where we left off. All right, let's try the opposite. Can you write these expressions as powers of 10? So write 1 over 10,000 using a single exponent. So when we see this as a fraction, this should tell us we're writing this with a negative exponent. So how do we know? So we count how many zeros are after the 1. So 1, 2, 3, 4. So it tells us it's going to be 10 to the negative 4th power. Right? 1 over 100 million as a single exponent. So we're going to put 10 to the negative, Let's count how many zeros. We have 2 plus 3 more is 5 plus 3 more is 8. 10 to the negative 8th. Let's write this as a single exponent. So we see this as a decimal. So that tells us we're doing this opposite here. So what we have to do is we're going to count how many decimal places do we need to go to get behind 1. So it's going to be 1, 2, 3, 4, 5, 6. And why it's negative? Because it's less than 1, but greater than 0. It's a pretty small number, but it's still bigger than 0. So it's going to be 10 to the negative 6. All right, kind of the same deal. It's going to be 10 to the negative something, but we have to count how many place values we're going. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be 10 to the negative 10th. All right, some people think they can just count the zeros in these decimals, but you need to include the first move to get around the 1, 2. All right. So based on the patterns you saw in the table, what do you suppose the rule is for writing 10 to the negative exponent as a fraction? Think about that. All right, our rule is we move the base of 10 to the denominator and make the exponent positive. That's it. So if we had 10 to the negative 6 and we wanted to make this into a positive, or make this into a fraction, we would move this 10 to the 6 to the denominator of a fraction and put 1 as our numerator. And when we do that, this negative exponent becomes positive. So if we did 10 to the negative 15th, we put it as a fraction, it'd be 1 over 10 to the 15th. To negate is to perform the opposite or inverse operation. All right, so we have a negative 15. We want to negate that negative. We don't like to have our solutions have a negative exponent. So to make it positive, we have to make it into a fraction, 1 over 10 to the 15th. So this is considered the inverse. So think of this as 10 to the negative 15 over 1. We're going to do the inverse. So 1's now going to be on top. 10 to the negative 15 will go to the denominator, which when we move it down to the denominator, it now becomes positive. So we like to write or simplify our answers so that they have positive exponents. So here's our rule. If we have a negative exponent, 10 to the negative exponent, it equals 1, the numerator 1, over 10 times a positive exponent. So these would become opposites, inverse. So here's why it works. So if we have 10 to the negative third, by having a negative exponent, we know that we have to multiply by 1/10. And we have to do that 3 times because it tells us our exponent is 3. So 1/10 times 1/10 times 1/10 be 1 times 1 times 1 is 1. And then 10 to the third would be our bottom number because it's factors of 10 multiplied times itself 3 times. So we have a few more problems for you to work through. So open up your workbook to page 31 and look at number 1. If you don't have your workbook, that's okay. You can still follow along. All right, so we want you to write each expression with a single exponent. So here's our example. If we had 1/10 times 1/10, so how would that look like? By seeing that we're multiplying by 2 fractions of 1/10, that should tell us that our exponents could be negative. And how many are there? There's 2. And we're dealing with base of 10, so it's going to be 10 to the negative second. So but we want you to have our answers in a positive exponent by using positive exponents. So here we go. Try these on your own before revealing your answers. So if we had this 1/10 times 1/10 times 1/10. So by seeing that we're multiplying by the fraction of 1/10, we should know that it's going to have a negative exponent, a base of 10, and we know that we're multiplying 1/10 times itself 3 times, so it's going to be negative 3. But we want to make this into a positive exponent. So I'm going to make this into a fraction by saying 1 over 10 to the third. So think of this as 10 to the negative 3 over 1, and we're taking the inverse. So we're just going to flip it. 10 to the negative 3 goes to the bottom. 1 will come to the top of the numerator. And when we flip it, this negative now becomes positive. All right, this one. Why don't you take a minute to do this one? All right, let's do it. So what we have to do, order of operations first. Let's take care of what's in the parentheses first. So it's 1/10 times 1/10 times 1/10. So that should tell you it's going to be 10 to the negative 3 inside. But then we still have this 3 on the outside of our parentheses. So we have power to power. So we have negative 3 times 3. So we have 10 to the negative 9th. But we want to go one more step. We want to make this a positive exponent. So that means we need to have it as a fraction just like this. So we are going to take the inverse of this. It becomes 1 over 10 to the 9th. All right, let our numbers get a little bit bigger. So we have 1, 2, 3, 4, 5, 6, 7. So it should be 10 to the negative 7th. We want to make that positive, so we're going to make it into a fraction, 1 over 10 to the 7th. This one, we got 2 steps just like we did over here. So we have 1, 2, 3, 4 of them. So it's going to be 10 to the negative 4th. But we still have that exponent of 2. So negative 4 times 2, because we know it's power to the power, we're going to multiply our exponents. Negative 4 times 2 is negative 8. We can't keep our answer with a negative exponent, so we have to make it into a fraction. So I'm going to take the inverse, so it'll be 1 over 10 to the 8th. Our last example on this slide, 10 times 10 times 10 would be 10 to the 3rd. Then we have to square that, or times to the negative 2. So we're going to take our exponents, as it's 10 to the 3rd, all raised to the power of negative 2. Multiply those. 3 times negative 2 is negative 6. We can't keep our answer as a negative exponent, so we're going to make it as a fraction, so 1 over 10 to the 6th. If you are not understanding this yet, please ask Ms. Kumber or myself. We can help you along the way. So I want you to try these. How would you write these expressions as decimal? So pause the video, try to come up answering both these questions, and we'll come back and answer them together. All right, so if we have 10 to the negative 4th, let's look at that one first. How we would do this. So think of our decimal at 1, right here. We always start at 1. And we are going to move, our number is small, okay? Because we should know that when we have a negative exponent, our number is going to look tiny. So I'm going to move this 4 places to the left. 1, 2, 3, and I don't have a lot of room here. Let me show you. If our decimal was here, we're going to move it 4 places to the left. 1, 2, 3, 4. So this one, oops. This one, we have 1, 2, 3, 4, 5, 6, 7, 8. So we're multiplying 1/10 times itself 8 times. How would we write that? Right now, so we think of our decimal after the 1. We're going to move it 8 places to the left. 1, 2, 3, 4, 5, 6, 7, 8. There we go. So try these. Write your answers with positive exponents. So we're kind of combining what we learned yesterday and the day before on these. So pause the video and we'll go through these shortly. All right, let's go through these answers. Okay, we're multiplying powers. So what we have to do is add our exponents. Negative 6 plus negative 2, we have like signs, so we're going to add them together. So it's 10 to the negative 8th. But we have this negative exponent. We want to make it positive because that's what the direction tells us. So I need to do the inverse of this. So it's going to be 1 over 10 to the 8th. Remember, when we bring this down to the denominator, our negative exponent now becomes positive. When we're dividing powers, we subtract our exponents. 3 minus 7 is negative 4, so 10 to the negative 4th. I want to get rid of this negative 4 as an exponent, so I want to make it positive because the direction tells us. So I have to do the inverse, so it becomes 1 over 10 to the 4th. So going back to kind of explain what happened on the first one, 10 to the negative 6, so that's 1/10 times itself 6 times, 1, 2, 3, 4, 5, 6. And then we have this times 10 to the negative second. So that means we're going to multiply 1/10 times itself twice because it tells us. And to come up with the -8, so we had 6 here and 2 here. We're going to add those together. 6 plus 2 is 8. That's where we get the -8. On this one, we have 10 to the third. So that means 10 times 10 times 10. So 10 times itself 3 times. And then 10 times to the 7th power. That means 10 times itself 7 times. This one we can eliminate some. Let's cross out like terms from the top and bottom. We're eliminating. All right, eliminate everything in the numerator. That doesn't mean it's gone. There's a 1 here now. So when there's nothing there, we always assume it's a 1. And then we have 1, 2, 3, 4, 10 to the 4th power. So it's going to be 1 to the 4th, or 1 over 10 to the 4th power. On this one, we have a power to a power. So we take -4 times 9 is -36. We need to make that to get the inverse because I want it to be positive. So it's going to be 1 over 10 to the 36th. So you could think of this as 1/10 times itself 4 times, because that's telling us. We use 1/10 because it's a negative exponent, and then do that to the 9th power. All right. So here's our big ideas for this lesson. Multiplying by 10 increases the exponent. Multiplying by 1/10 decreases our exponent, so it gets smaller. Negative exponents can be thought of as repeated multiplication of 1/10. Positive exponents can be thought of as repeated multiplication of 10. And multiplying by 10 or 1/10 affects the placement of our decimal. So think of if we're multiplying by 10, our number's getting bigger, so our decimal is going to move to the right. If we're multiplying by 1/10, we are going to be moving to the left because our number's getting smaller. So our target we accomplished. I know what it means if 10 is raised to a negative power. So that's it for today. There's another quizzes activity today. You can find the link and the code in the Schoology update. Let us know if you have any questions.